But wait, you might ask me, what is a sequence? We haven't really learned about sequences yet. So before we can see an example of this actual for loop in use, we have to know what can we fill in here for a sequence. So for loops need some sort of sequence to iterate over. And this is so common, such a common requirement, that Python gives us a handy function to create sequences of numbers. Specifically, getting a sequence of numbers is so common. And this is called range. So this range function takes some arguments, and using those arguments creates a sequence of numbers that you can then iterate through in your for loop. This range function, you'll see, can take either 1, 2, or 3 arguments. And we're going to look at all 3 of those possibilities here so you know when to use which. So the easiest, simplest version is the version that takes just 1 argument. And so when you have range that takes 1 argument, a single number, then that argument represents the end of what our sequence goes up to. And this will create a sequence that counts up from 0, starting from 0, to the end that we specify, not including that number, and it counts up by ones. And so range 6 will be a sequence of 0, 1, 2, 3, 4, 5. Not 6 because the end number is exclusive, so we go up to but not including the end. Same thing here, if we have 0, if range 2, that gives us a sequence of 0 and 1, but not 2. Range 1 is just 0. And you might ask, oh, well, what if I have a negative end? Well, if you start from 0 and then count up to a negative number, you get nothing. So you get an empty sequence. And so we can go over to Replit here and just see this in action. If I create a range up to 5, and I have to use this list function to make it print out nicely as a list. We'll learn more about lists later in this class. But just for the purpose of showing what kind of sequence this generates, range 5 gives us 0 through 4 by ones. Range 10 and 0 through 9. So that's the 1 argument version of range. Gives us the sequence. What about 2 arguments? The 2 argument version is the same as the 1 argument version, but instead of assuming that you start from 0, you can specify here exactly what number you want to start from. So you'll notice here, range 0, 6 is actually the same thing as range 6. We get the same 0, 1, 2, 3, 4, 5, because when you only have 1 argument, the range function assumes that you're starting to count from 0. With 2 arguments, you're providing both the start counter and the end number that we're counting to, but we still assume that we're counting by ones. And here the start is inclusive, so when you do range 0, 6, you're counting starting from 0 by ones up to but not including 6. So we get 0, 1, 2, 3, 4, 5. Range 2 to 6 gives us 2, 3, 4, 5. Again, not including 6. And here we can start from 5 if we want for this third example, going up through but not including 10, 5, 6, 7, 8, 9. Just to play with this, so 0, 10 gives us the same exact output that we had when it was just range 10. But maybe we want to start from 8. So that gives us 8 and 9. Not 10 because the end index is exclusive. And finally, we have the 3 argument version of range. So here you specify not only the start and the end, but you also specify the step size, meaning what increments you want between numbers. And so here, again, notice range 0, 6, 1. So that means we're starting from 0. We're counting up to but not including 6. And we're going to take steps of size 1. This gives us a sequence of 0, 1, 2, 3, 4, 5, which is the same as the sequence we got from 0, 6, range 0, 6, or just range 6. Because range 6 the same thing as range 0, 6, 1, because we're starting from 0, which is what range assumes, with one argument, and we're taking steps of size 1, which is also the default for the one argument range function. Same thing here as we go on to same rules here for these other examples. We can start from 2 and count up to but not including 6 with step size of 1. What gets more interesting is, what if we want to have a step size of 2? So we want to go up by 2s. Here we can get our even numbers, starting from 0, counting up through 10, but not including 10. So range 0, 10, step size of 2 gives us 0, 2, 4, 6, 8. Looks like I have the same example twice here. But our last example here is novel. You can actually have negative steps. So you could start from 5, counting to 0, with a step size of -1. And so that means that from 5, the next number, you're going to subtract 1 or add -1. Okay, you get 4, add -1, you get 3, so on and so forth. Up to, but not including the end number. So that's why when we go from 5 to 0, we start with 5, 4, 3, 2, 1, but we don't get to 0 because the end number is exclusive. So we can play with that here. So let's say we want to do 0 to 100. Well, that'll be a pretty long list if we just have step size 1. If I run this, got a nice big list. But if we want to take step size 15, we just get the multiples of 15. Or step size 10, get the multiples of 10. Again, not including 100, because the end number is exclusive. Now let's actually apply for loops using these ranges that we've learned. So here's an example. For I in range 5, print I. What's going to happen here? Well, range 5 will first get evaluated. So that is going to be an expression that evaluates to a sequence of the numbers 0 up through 4. So range with just one argument is we create a sequence starting from 0 going up to whatever the argument value is, taking steps of size 1. So 0, 1, 2, 3, 4. And then what Python is going to do is it's going to execute, first assign I the first value in the sequence, which is 0, and then execute the entire body, so everything that's indented after this original for statement with the colon at the end, all of those lines, which here is just one line. And so we see that 0 gets printed out, I gets printed. Then as soon as it reaches the end here, it's going to go back and assign I the next value in the sequence and execute the body with that value of I. So we print 1. And this pattern continues. So as soon as the body is done being executed, if there are any numbers still left in the sequence, or any items still left in the sequence, we go ahead and update the value of I to the next value in the sequence and print out that value, I. In this case, execute the body, which is to print I. So we continue. Finally, when I is equal to 4, the body gets executed. At the end of executing the body, 4 gets printed. And Python sees that there's nothing left in the sequence. We assigned I to the last value of the sequence to I. And so now our for loop ends and nothing else happens. We go on to execute the next lines and no more looping occurs here.